Before we start, I want to mention this important question that on what factors the work function of metal depends. It depends upon two factors. One, the lattice structure or molecular arrangement of metal, and second, the chemical composition of surface. So if question is that how can we decrease the work function or increase the work function of metal, then the simple answer is that we coat the surface of the metal with some composition which can reduce the work function of metal surface. Now come to the numericals. We need to remember four formula. The formula number 1, energy of photon is equal to h nu, where h is Planck's constant and nu is frequency of light photon. Or nu can be written as c upon lambda. So energy is also written as hc upon lambda. Work function or the minimum energy required by the photoelectron to leave the metal surface is h nu naught, where nu naught is threshold frequency. Then Einstein's photoelectric equation, kinetic energy maximum which a photoelectron can have is equal to photon's energy, light energy, h nu minus work function of the metal. And maximum kinetic energy of electron can also be written as charge of electron into stopping potential. Stopping potential is that negative potential of anode which can make the photocurrent zero by stopping the maximum energy photoelectron to reach the anode. Here h is Planck's constant and lambda is wavelength of light incidenting and lambda naught is wavelength, threshold wavelength, and V naught is stopping potential. Next important point is that electron volt is unit which we use in atomic physics to represent the energy. And this electron volt unit is actually calculated by multiplying charge of electron with the value of potential difference in which this electron is moving. If we place the potential difference equal to 1 volt, then charge of electron into 1 volt will give you 1.6 into 10 to the power minus 19 value, and coulomb into volt will give you the unit joule. So 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. Now mostly in numericals we will be given wavelength in Armstrong or nanometer and energy we need to calculate in electron volt. So if we want to convert electron volt into joules, we should know that we have to multiply the value of energy with 1.6 into 10 to the power minus 19. And if we want to convert the energy given in joules into electron volt, then we need to divide the energy with 1.6 into 10 to the power minus 19. 1 electron volt is energy gained by electron if that electron is moving in potential difference of 1 volt. Now, good thing about the numericals of photoelectric effect is that these all numericals you will find similar, and you will find that they are solved with following similar steps. So let us see one numerical, and we will find that all other numericals can be solved if we understand this one numerical. Here, the wavelength of incident light is having wavelength 300 nanometers. Stopping potential applied in the tube is 0.54 volt. Hc and 1 electron volts relation with joule is given. And question is find energy of photon, maximum kinetic energy of photoelectron, and work function of metal. We will start with energy of photon, and here I wish if you understand how to represent your numericals in board copy. First, you are supposed to write the formula used. The second very important step is substitute the values of the quantities and show it in your copy. And then this H into C, which will give you actually, if you calculate it, will give you the answer in joules, but you need answer in electron volt. So here we will use a simplified shortcut. See this formula. Hc, it is known, and if you substitute Hc and lambda in their SI units, then whatever energy you are getting, that will be in joules. But as I said that you will mostly have answers and as well as the given data in electron volt if it is energy, and Armstrong or nanometer if it is wavelength. So we modify this formula so that we can easily apply it everywhere. We will substitute Hc, the values. The lambda will be substituted if is in Armstrong, and dividing the value which is coming in joules by charge of electron and converting this whole energy in electron volt, we get a simplified shortcut formula. That is, if you calculate energy in electron volt, then you will use the formula 12400, which is the result of the known quantities we have substituted here. Calculating this, we get 12400 or 12375. Both will give you approximately same answer, and divided by lambda in Armstrong. So this is the shortcut, that you will get energy in electron volt if you divide 12400 by the wavelength's value given in Armstrong. So substitute the values, show this substitution, but to reduce your calculation, use this shortcut in place of this. So now let us come to our numerical. I have written the value of Hc and I will write lambda in Armstrong. Showing that I have substituted these values, I will come to this approximation or the shortcut formula, and 12400 divided by lambda in Armstrong, it is 300 nanometer. So in Armstrong there will be 10 extra, and the answer will be 4.13 electron volt, that is the energy of the photon. So pay attention how you are supposed to write the answer numericals in your board copy. See, the quantity E is being calculated, proper equal sign is given here, and then substitution of the values in the respective formula, and then stepwise the calculation is being showed. For maximum kinetic energy, we will use here formula EV0 because stopping potential is given here, and we will substitute the value of V0 and E. Whatever answer we are getting here, that will be in joules. And if you want to convert joule into electron volt, which is mostly being asked in the numerical, that give answer in electron volt, then you need to divide it with this value. What are you left with in your answer? Same value, which is the value of a stopping potential, but this time unit will not be volt, but it will be electron volt. So what conclusion we draw here? We draw conclusion that if energy is given in electron volt and you are asked to calculate stopping potential, simply write the value of energy and unit volt, your answer will be ready. If you are given a stopping potential in volt and you are asked to calculate maximum kinetic energy in electron volt, then simply write the value of the potential difference, but write the unit of energy and your answer is ready. So actually you don't need to calculate anything. Write the formula and your answer will be same value as given in a stopping potential's value, and unit instead of volt, electron volt. Then work function can be calculated using the Einstein's equation. That is, kinetic energy maximum of a photoelectron is photon's energy minus work function. So work function is equal to energy of photon minus kinetic energy. Substitute the value we calculated in the upper steps and find the answer. Write the formula in the box used and answer in the box. Always show the values substituted in the formula and then write the third step, that is the answer. Second type of question from this topic will be, you will be asked definition or question which is given, which is asking you why this happens or the factors on which a particular quantity depends. So like here, you can see how many times this question is being asked, what is threshold frequency and how does it depends upon the intensity of light. So first I have written the definition of threshold frequency, and after that, to give the answer of the second part, see how we need to answer. Intensity of light is energy incidenting per unit time per unit area. So the formula of intensity is number of photons incidenting per unit time per unit area of metal into energy of one photon. Now since if intensity is changed, actually number of photons incidenting per unit time per unit area will change. Now since threshold frequency is characteristic of metal surface, and if you change intensity, you are changing number of photons incidenting on the metal surface per second per unit area. So answer will be that if intensity is changed, there will be no change in threshold frequency because it is characteristic of the metal surface. Similarly, if the question is being asked what is cutoff potential, then you will write the definition and after that you will show that maximum kinetic energy of photoelectron is related with the threshold with the stopping potential through this relation. And then third type of question is the question of graph. Like here, this is very important question for this semester also, that plot labeled graph of stopping potential and frequency of incidenting radiation. How will you use this graph to determine Planck's constant? So I will discuss both kinetic energy versus frequency and stopping potential versus frequency graph. If it is kinetic energy maximum, which is E into V, and frequency graph, then on x-axis frequency, on y-axis kinetic energy. This is the relation of the equation representing here, that maximum kinetic energy is h nu minus h nu naught. So h nu, here h is slope of the graph and nu is the x variable plotted on x-axis. Kinetic energy maximum is y variable, and this third part is the intercept on y-axis in negative y direction. Labeling, you need to point here that the point where graph is cutting x-axis is threshold frequency. The slope of the graph is actually representing h, the Planck's constant, and intercept on the negative y-axis is representing directly the work function. But if the graph is between a stopping potential and frequency, then we need to modify this equation. Divide this equation with E. So here we will be left with V naught is equal to h by E nu minus W by E. So now the slope of the graph will represent not the Planck's constant directly, but the Planck's constant divided by charge of electron. And intercept will not represent work function, but work function divided by E. So here this point will still represent threshold frequency, but slope of the graph and intercept of the graph will represent h by E and W by E respectively. So you can see that numericals and questions of photoelectric effect are quite simple and easy, and since all the numericals are almost same except the quantities, so I will not explain rest of the numericals because it is same as we did the first numerical. So I'm showing you the solution. You can pause video and can solve the problems by yourself. PDF of this whole handwritten content is available on my Telegram channel, which will be given in the description box and which will flash at the end of the video also. This question is being asked in 2008. In 2013 again, work function is being calculated. 2 years this question is being asked, and see, stopping potential is being asked here. In 2005 the question is asked again the same quantities, work function, maximum kinetic energy and stopping potential. Again in 2012 same question, work function. In 2013 the question is giving you work function of two metals, and the question is asking which one will have lower threshold wavelength. When I was correcting answer in pre-board exam, I have seen that children has written so many things which you actually don't need to write. Just write the formula used, formula for work function, then from formula derive that work function is inversely proportional to wavelength, threshold wavelength. Therefore, the metal which is having higher work function will have lower threshold wavelength, and therefore metal B has lower wavelength. So actually you need only 3 steps to write the answer and get the full marks. Here it is how you need to represent the theoretical question in which definition is asked. As I said, this is also very important question of graph. You can be given values here, and you can be asked to calculate work function. So if threshold frequency you read from the graph given in the question, then you can simply multiply h with nu naught and can calculate work function. Or you can directly find it from the calculation of intercept. Here again you can see that wavelength of the incident radiation is being asked, and the same formula, that is minimum energy required is equal to work function. So calculate work function, and after that using the formula for work function, you can calculate minimum energy of photon, that is minimum wavelength of photon required to show the photoelectric effect. In this question again, Einstein equation of photoelectric effect is being asked. So this equation itself is a answer, but here you need to know that we have to mention the quantities which the symbols used in equation are representing. In this question, threshold frequency definition is being asked, and does it depends upon intensity of light? So we will simply write, as I already discussed, that since work function is property of metal, so it does not depend upon intensity of light. In 2019, an important question is asking that which color light will have maximum energy, and we know that the color which is having maximum frequency or minimum wavelength will have maximum energy. So the answer will be violet. In this question again you can see that energy of photon and work function is being calculated. So this is all about the numericals and important questions of photoelectric effect. The 2 videos on photoelectric effect are covering whole syllabus and all the important questions which are possible in your semester 2 exam.